Welcome to your practice question review for WGU Health, Wellness and Fitness. Every question mirrors the real exam we break down. Why the right answer works, why others fail, and the concept behind it. Domain 1 covers human body systems, including levels of organization and tissues, homeostasis, the skeletal and muscular systems, the nervous and respiratory systems, the cardiovascular and digestive systems. Our website offers free exam guides and practice questions designed to help you ace your C458 exam. Everything you need to succeed is just a click away. Simply check the link in the description below to access these resources and start studying smarter, not harder today. All right, let's jump in. Question 1. A student examines heart tissue under a microscope and correctly identifies it as muscle tissue. Moving up exactly one level of organization from tissue, what does the heart itself represent? Your options are A cell, B, an organ system, C, an organ, D, the chemical level. Which one is it? Pause the video if you need more time. The correct answer is C, an organ. C is correct because an organ is made of two or more tissue types and performs a specific job. So the heart, built from muscle and other tissues, sits at the organ level just one step above tissue. A is wrong because the cellular level sits below tissue, not above it. A single muscle cell is one level simpler than muscle tissue, so moving up cannot lead back to a cell. B is wrong because an organ system is several organs working together, such as the whole cardiovascular system, that is two levels above tissue, not the next step up. D is wrong because the chemical level of atoms and molecules is the simplest level of all, far below tissue, so it cannot be reached by moving upward. The human body is built like a staircase, climbing from the simplest chemicals all the way up to the complete living organism, with each step built from the one below it. The order runs chemical, cellular, tissue, organ system, and organism. Similar cells working together form a tissue. Two or more tissues form an organ. Cooperating organs form an organ system. And all the systems together form the organism. The heart makes the organ level concrete. It's not one tissue, but four working together. Muscle tissue that contracts, connective tissue that holds its shape, nervous tissue that times its rhythm, and blood vessels that feed the wall itself, all bundled into one structure with one job. Test writers love the gap between organ and organ system. A single bone is an organ, but the whole skeleton is an organ system. The stomach is an organ, but the stomach working with the mouth, esophagus, and intestines forms the digestive system. Moving up from tissue always leads to organ, never back down to cell. Holding this fixed order in mind turns every placement question into simply counting steps on a familiar staircase. Question 2. A physiology instructor asks which of the four basic tissue types is directly responsible for producing movement in the body. Which tissue type is the correct answer? Your options are A, muscle tissue, B, epithelial tissue, C, connective tissue, D, nervous tissue. Take a second. Which answer would you pick? The correct answer is A, muscle tissue. A is correct because muscle tissue is defined by its ability to contract, and that contraction is what produces movement throughout the body. B is wrong because epithelial tissue covers body surfaces and lines cavities, such as the skin and organ linings. It forms barriers rather than generating movement. C is wrong because connective tissue supports and connects structures, including bone, blood, and fat. It holds the body together but does not contract. D is wrong because nervous tissue transmits electrical signals to carry information. It can trigger movement but does not perform the contraction itself. The body is built from only 4 basic kinds of tissue, and every organ on the anatomy chart is some blend of them. Learning what each one does turns a long, intimidating list of organs into something predictable. Epithelial tissue covers surfaces and lines cavities. Connective tissue supports, binds and fills space between structures. Muscle tissue produces movement through contraction, and nervous tissue generates and carries fast electrical signals. Muscle earns its title through one ability the other 3 simply lack: contraction. A muscle cell actively shortens itself and pulls on whatever it's anchored to, whether that's a sprinter's legs, the gut squeezing a meal along, or the heart beating for a lifetime. The classic trap is assuming movement comes from nerves, since they're obviously active whenever the body moves. But nerves only carry the command. The signal travels down the nerve, crosses a tiny gap, and only the muscle shortens to create movement. Epithelium covers, connective supports, muscle moves, and nervous communicates. Once those 4 verbs are locked in, any unfamiliar organ becomes far less mysterious. Question 3. An anatomy text groups bone, blood, fat, and tendons together under a single tissue category because they all support or connect other body structures. Which tissue type is being described? Your options are A. Epithelial tissue, B. Connective tissue, C. Muscle tissue, D. Nervous tissue. Before I reveal it, which one do you think is right? The correct answer is B. Connective tissue. B is correct because connective tissue is the category that supports and connects body structures, and it includes bone, cartilage, blood, fat, ligaments, and tendons. A is wrong because epithelial tissue lines and covers surfaces such as the skin and the inside of organs. Bone and blood are not surface coverings. C is wrong because muscle tissue contracts to produce movement. Bone and fat do not contract, so they do not belong here. D is wrong because nervous tissue transmits electrical impulses. None of the listed structures carry nerve signals as their main job. Connective tissue is the body's great supporting cast, the family that holds everything else in place. Its defining feature sets it apart from every other tissue type at a glance. Instead of cells packed tightly together, connective tissue is mostly matrix, a background material with cells scattered thinly through it. That matrix can be hard as stone, firm and rubbery, or fully liquid, which is how one family includes both a thigh bone and a drop of blood. Bone gives the body its rigid frame. Cartilage cushions joints. Ligaments strap bone to bone, and tendons tie muscle to bone. Fat stores energy and pads organs, while blood carries materials through a fluid matrix. The shared thread across all of them is a supporting role, not a particular shape. In bone, the matrix is hardened with calcium, so it resists crushing. In cartilage, the matrix is firm but flexible, bending without snapping. In blood, the matrix is plasma, a watery liquid that lets cells and nutrients drift along the flow. Blood and fat count as connective tissue not because they glue things together, but because they share that structural pattern and a broad supporting function. And remember the key contrast: epithelium forms covering sheets, while connective tissue sits beneath, anchoring and supporting everything else. Question 4. On a hot day, a person begins to sweat, and the blood vessels near the skin widen to release heat, keeping internal body temperature near its normal set point. This coordinated effort to hold internal conditions within a stable range is best described as what? Your options are A. Metabolism, B. Respiration, C. Digestion, D. Homeostasis. What's your answer? Commit to one before I continue. The correct answer is D. Homeostasis. D is correct because homeostasis is the state of balance the body maintains by keeping internal conditions such as temperature within a narrow livable range. Sweating and widening surface blood vessels to shed heat are textbook homeostatic responses. A is wrong because metabolism refers to the chemical reactions that release and use energy. It is not the concept of holding internal conditions steady. B is wrong because respiration is the exchange of oxygen and carbon dioxide. It is one process the body regulates, not the balancing concept itself. C is wrong because digestion is the breakdown of food into absorbable molecules and has nothing to do with cooling the body. Homeostasis is the balance among body systems that keeps us alive and functioning. Conditions like temperature, blood glucose, and blood pressure are held within narrow, livable ranges through constant small adjustments, never actually standing still. This balance matters because cells are fragile. Too hot and proteins fall apart, too cold and reactions crawl to a halt. Too little water and cells shrivel, too much and they burst. So the body wraps them in a stable internal environment. The mechanism follows a loop. A sensor detects a value has drifted, a control center compares it to the target, and an effector acts to push it back. This is called negative feedback because the response always opposes the original change. Consider blood glucose after a meal. As sugar is absorbed, glucose rises. The pancreas senses this and releases insulin. Cells pull glucose from the blood, and levels ease back into range. No conscious effort required. Homeostasis isn't an organ you can point to on a diagram. It's a job shared by many systems. The nervous system corrects fast with electrical signals. The endocrine system corrects slowly with hormones, and the urinary system balances water and salt. Question 5. Which sequence correctly lists the body's levels of organization from the simplest level to the most complex? Your options are A. Chemical, cellular, tissue, organ system, organism. B. Cellular, chemical, tissue, organism, organ system. C. Tissue, cellular, organ system, organism, chemical. D. Organ system, tissue, cellular, chemical, organism. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is A. Chemical, cellular, tissue, organ system, organism. A is correct because the body builds from the simplest chemical level of atoms and molecules up through cells, tissues, organs, organ systems, and finally the whole organism, with each level made from the one below it. B is wrong because this places the cellular level before the chemical level, but atoms and molecules make up cells. So chemical must come first. It also ends with the last two levels reversed. C is wrong because this begins with tissue and pushes the chemical level to the very end, scrambling the true bottom to top order. D is wrong because this starts near the middle with organs and inverts the hierarchy, which does not reflect how simpler levels build into more complex ones. The body is built like a staircase, running from the simplest chemistry up to the whole living person. 6 levels stack in strict order: chemical, cellular, tissue, organ system, organism. Each rung is assembled from the one below it, so the sequence traces how nature actually builds a body. At the foundation are atoms and molecules. The chemical level, which combine into the cell, the smallest thing biology calls alive. Similar cells form a tissue. Tissues combine into an organ, and organs link into an organ system, until every system together builds the whole organism. This is the real heart of the hierarchy. Each level gains an ability the level below it cannot manage alone. A single heart muscle cell can twitch on its own, but it cannot pump blood to a toe. Only the fully assembled heart, joined to the vessels, can circulate blood through the entire body. One thread climbs cleanly through all 6 levels. Atoms build a protein molecule. Proteins build a muscle cell. Muscle cells build muscle tissue. Tissue builds the heart, and the heart with vessels builds the cardiovascular system. Whenever a question asks where something fits or what comes next, recite the ladder from smallest to largest. That fixed order settles every placement question the topic can throw at you. Question 6. The human skeletal system provides the body's rigid framework and accounts for roughly 1/5 of total body weight. How many bones make up the typical adult skeleton? Your options are A. 6, B. 2/7, C. UCNC, D. 3. Which would you go with? Lock it in before the reveal. The correct answer is C. 206. C is correct because the typical adult skeleton contains 206 bones. The standard count after the extra bones present at birth fuse together during growth. A is wrong because 186 is simply too low and is not a figure tied to the adult skeleton. B is wrong because around 270 bones is closer to the count a newborn has. Many of those fuse during childhood, lowering the adult's total. D is wrong because 320 overstates the count. The number falls as a person matures rather than rising above the birth figure. The adult skeleton is made of 206 bones, about 1/5 of body weight, and far from being dead struts. Bone is living tissue with its own blood supply, nerves, and constant repair crews. A newborn actually has closer to 300 separate bones. As a child grows, many of these fuse together, especially in the skull and lower spine, so the running total falls rather than climbs, settling at 206 by adulthood. The skeleton does far more than hold the body upright. It protects organs like the brain and heart, gives muscles something to pull against for movement, banks calcium and phosphorus for the blood, and inside certain bones, red marrow manufactures red cells, white cells, and platelets. Deep inside certain flat bones, like the breastbone and the hip, red marrow runs a steady production line, manufacturing red blood cells, white blood cells, and platelets, tying the skeleton directly into the cardiovascular and immune systems. Keep bones separate from cartilage nearby. Bone is hard, mineral-packed, and richly supplied with blood, while cartilage is firm but flexible with almost no blood supply, though both belong to the same connective tissue family. Question 7. A bone that is roughly cube-shaped, with length, width, and height that are about equal, such as a bone of the wrist, belongs to which of the 4 bone classifications? Your options are A. Long bone, B. Short bone, C. Flat bone, D. Irregular bone. Don't overthink it. Which one feels right? The correct answer is B. Short bone. B is correct because short bones are roughly cube-shaped, with dimensions that are about equal in every direction. The carpals of the wrist are the classic example. A is wrong because long bones are longer than they are wide, with the shaft and 2 expanded ends, like the femur of the thigh. C is wrong because flat bones are thin and often curved, such as the sternum and ribs. A cube shape does not fit that description. D is wrong because irregular bones have complex shapes that fit none of the other categories, such as the vertebrae of the spine. Bones are classified by shape into exactly 4 categories, and knowing that there are only 4 is half the trick, since a fake 5th category is a classic wrong answer. Long bones like the thigh and upper arm act as levers for movement. Short bones like those in the wrist and ankle form stable, shock-absorbing clusters. Flat bones like the skull and ribs shield organs and anchor muscle. Irregular bones like the vertebrae and hip handle complex multi-purpose jobs. Take the skull as an example of a flat bone. Its curved, plate-like structure both shields the brain underneath and gives muscles wide surfaces to anchor onto, doing 2 jobs with 1 shape. This is the real logic behind the system. A lever needs length, so movers are long. A shock absorber needs a compact block, so wrist and ankle bones are short. A shield needs a broad surface, so protectors are flat, and a complex anchor needs a complex form. So the spine and hip are irregular. So when a question describes a bone shape, just match it to one of the 4 classes. And remember, the system holds exactly 4, with no invented 5th category like round ever applying. Question 8. The shoulder allows movement in many directions, while the sutures of the skull permit no movement at all. The body's joints are grouped into 3 categories based on what characteristic? Your options are A. The number of bones they connect. B. The type of muscle attached to them. C. The minerals they store. D. Their range of movement. Got a guess? Lock it in. The correct answer is D. Their range of movement. D is correct because joints are grouped as immovable, slightly movable, or freely movable, a classification based entirely on how much they move. The skull sutures are immovable and the shoulder is freely movable. A is wrong because joints are not sorted by how many bones meet at them. The defining feature is mobility. B is wrong because the kind of muscle near a joint does not define the joint category. Range of movement is what separates the 3 groups. C is wrong because mineral storage is a job of bone tissue itself and has nothing to do with how joints are classified. A joint is simply where 2 bones meet, and without joints the skeleton would be one rigid cage that couldn't even nod. What makes joints useful for classification is a single measure, how much movement each one allows. Every joint falls into one of 3 groups. Immovable joints like the sutures of the skull permit no motion at all. Slightly movable joints like those between vertebrae allow small limited motion. Freely movable joints like the shoulder and hip allow wide motion in many directions. The skull shows the immovable extreme. Sutures lock bone plates together into a solid shield around the brain, trading motion entirely for stability. The shoulder shows the opposite extreme. Cartilage and ligaments allow huge freedom of motion at the cost of greater exposure to injury. The distinction to guard is that joints are sorted by motion and nothing else, not by the number of bones meeting or the muscles nearby. More motion means freely movable. No motion means immovable. And a small limited amount means slightly movable, the category sitting right between the 2 extremes. Question 9. A basketball player tears the anterior cruciate ligament, which attaches the thigh bone to the shin bone and stabilizes the knee. Based on what it connects, the ACL is an example of which structure? Your options are A. A ligament, B. A tendon, C. Cartilage, D. Smooth muscle. Which one is it? Pause the video if you need more time. The correct answer is A. A ligament. A is correct because a ligament binds one bone to another, and the anterior cruciate ligament connects the thigh bone to the shin bone to stabilize the knee. Joining bone to bone is the signature of a ligament. B is wrong because a tendon attaches muscle to bone, like the Achilles tendon joining calf muscle to the heel. The ACL joins 2 bones, not a muscle to a bone. C is wrong because cartilage covers the ends of bones to prevent friction. It does not strap 2 bones together the way the ACL does. D is wrong because smooth muscle lines internal organs and blood vessels and plays no role in holding the bones of a joint together. A ligament is a band of connective tissue that binds one bone to another. That single phrase, bone to bone, is the whole identity of a ligament and the key to telling it apart from everything it gets confused with. Freely movable joints are naturally loose, so ligaments act like straps stretched across them, allowing normal motion while firmly blocking the extremes that could cause a tear. The classic example is the anterior cruciate ligament, or ACL, which runs inside the knee and attaches the thigh bone to the shin bone, holding the lower leg from sliding forward during running, cutting, and landing. Ligament tissue shares cartilage's weakness, a poor blood supply, so a torn ligament heals slowly and incompletely, which is why a serious ACL tear often means surgery followed by many months of rehabilitation focused on strengthening the surrounding muscles. The distinction examiners press hardest is ligament versus tendon. A ligament links bone to bone, while a tendon ties muscle to bone, and cartilage simply cushions where bones meet. Remember, ligament links, sharing that first letter, so whenever the scenario is bone to bone, the answer is ligament. Question 10. The Achilles tendon connects the calf muscles to the heel bone. Based on this connection, what does it tell you about the general function of a tendon? Your options are: A. It binds one bone directly to another bone. B. It cushions the joint where two bones meet. C. It attaches muscle to bone to aid movement. D. It stores calcium for release into the blood. Take a second. Which answer would you pick? The correct answer is C. It attaches muscle to bone to aid movement. C is correct because a tendon attaches muscle to bone so that when the muscle contracts, it pulls the bone and creates movement. The Achilles tendon links the calf muscle to the heel bone to lift the foot. A is wrong because binding one bone directly to another describes a ligament, not a tendon. B is wrong because cushioning the point where two bones meet describes cartilage, which keeps the bones from rubbing. D is wrong because storing and releasing calcium is a function of bone tissue itself, not of the tendon attached to it. A tendon is a tough cord of connective tissue that attaches muscle to bone. It's the structure that turns a muscle's pull into real motion of the skeleton. Trace the chain in full. A nerve signal makes the muscle contract and shorten. The shortening tugs on the tendon, and the tendon transmits that pull into the bone, which rotates around its joint. Remove the tendon and the muscle would shorten uselessly with nothing to deliver its force to the skeleton. The named example is the Achilles tendon, the thick cord connecting the calf muscle to the heel bone. When a sprinter pushes off the blocks, or a dancer rises onto the toes, the calf contracts and the Achilles tendon hauls the heel upward, lifting the body's weight off the ground. The point examiner's test is the mirror image of the ligament trap. A tendon ties muscle to bone, while a ligament links bone to bone, and cartilage simply cushions where bones meet. A torn Achilles shows this in reverse, since the muscle can no longer move the foot at all. Whenever a muscle needs to act on a bone, or the calf and heel come up together, that's a tendon at work, carrying force so movement can finally happen. Question 11. The body contains 3 types of muscle tissue. Which type is found only in the heart and contracts rhythmically and continuously without conscious control? Your options are: A. Cardiac muscle, B. Smooth muscle, C. Skeletal muscle, D. Connective tissue. Before I reveal it, which one do you think is right? The correct answer is A. Cardiac muscle. A is correct because cardiac muscle is found only in the heart, where it contracts rhythmically and continuously for a lifetime without any conscious command. B is wrong because smooth muscle lines internal organs and blood vessels, not the heart wall, so it is not limited to the heart. C is wrong because skeletal muscle attaches to bones and is under voluntary control. It is spread throughout the body rather than confined to the heart. D is wrong because connective tissue is not a muscle type at all. It supports and connects structures such as bone and cartilage. Of the body's 3 muscle types, cardiac muscle has the strangest story. It lives in only one place, the wall of the heart, and it looks like one kind of muscle while behaving like another entirely. Skeletal muscle attaches to bones and obeys conscious command. Smooth muscle lines internal organs and works on its own. Cardiac muscle sits in the heart alone, and that single organ restriction is the cleanest way to recognize it. Under the microscope, cardiac muscle shows the same striped banding as skeletal muscle, but special junctions called intercalated discs connect neighboring cells, letting an electrical signal jump rapidly between them so the whole heart contracts as one coordinated wave. Cardiac muscle is striated but involuntary, generates its own electrical impulse instead of waiting on a nerve, and contracts tirelessly without fatigue, but it barely regenerates. So during a heart attack, dead muscle is replaced by scar tissue that cannot contract, permanently weakening the heart's pumping power. Don't see stripes and assume skeletal, or see involuntary and assume smooth. Cardiac muscle splits the difference, belonging to neither, and lives only in the heart. Question 12. A medication relaxes the muscle in the walls of the intestines and blood vessels. Smooth muscle lines these internal organs. Which statement about smooth muscle is correct? Your options are: A. It is under voluntary control and moves the bones. B. It is found only in the wall of the heart. C. It has a striped appearance and controls facial expressions. D. It works involuntarily and is also called visceral muscle. What's your answer? Commit to one before I continue. The correct answer is D. It works involuntarily and is also called visceral muscle. D is correct because smooth muscle, also called visceral muscle, works involuntarily and lines the walls of internal organs and blood vessels. A is wrong because moving the bones under voluntary control describes skeletal muscle, not smooth muscle. B is wrong because muscle found only in the heart is cardiac muscle. Smooth muscle is spread through many organs. C is wrong because a striped appearance and control of facial expressions describe skeletal muscle. Smooth muscle has no stripes. Smooth muscle, also called visceral muscle, lines the walls of internal organs. It gets its name from its unstriped, smooth appearance under the microscope, and unlike muscles you flex on purpose, it works entirely on its own. Smooth muscle turns up anywhere a hollow internal organ needs to change shape or move its contents: the digestive tract, blood vessels, the bladder and ureters, the airways of the lungs, and the uterus. Its contractions are slow, sustained, and rhythmic rather than quick and forceful. In the gut, this pushes the meal along steadily, and in blood vessels, a gradual change in tension widens or narrows the channel to redirect blood flow. This matters clinically. During an asthma attack, smooth muscle in the airway walls contracts too hard, narrowing the passage and making breathing difficult. Bronchodilators work by relaxing that same muscle to reopen the airway. Smooth muscle stands apart from the other two types. Skeletal muscle is striped and voluntary. Cardiac muscle is striped and involuntary but confined to the heart, while smooth muscle is unstriped, involuntary, and spread through the hollow organs and vessels of the body. Question 13. Under a microscope, skeletal muscle shows a pattern of alternating light and dark bands. What is the source of this striped or striated appearance? Your options are: A. The presence of intercalated disc between the cells. B. The organized arrangement of actin and myosin protein filaments. C. A coating of cartilage over the muscle surface. D. The branching shape of the individual muscle cells. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is B. The organized arrangement of actin and myosin protein filaments. B is correct because the stripes come from the highly organized, repeating arrangement of actin and myosin filaments inside the muscle fibers, which creates alternating light and dark bands. A is wrong because intercalated discs join cardiac muscle cells and help spread electrical signals. They do not create the banding pattern. C is wrong because cartilage covers the ends of bones at joints and has nothing to do with the appearance of muscle fibers. D is wrong because a branching cell shape is a feature of cardiac muscle, not the cause of the stripe bands in skeletal muscle. Striated muscle gets its name from the fine banded pattern visible under a microscope. Those stripes aren't decoration. They're a direct readout of how the muscle is built, and understanding them explains how muscle actually generates force. The organization runs through nested levels. A whole muscle is made of fibers, which are packed with myofibrils, and each myofibril is a chain of repeating sarcomeres. The sarcomere is the true working unit of contraction, and zooming in this far reveals the source of the stripes. Inside every sarcomere, thin actin filaments and thick myosin filaments overlap in a regular pattern. Where thick myosin sits, the band looks dark. Where only thin actin sits, the band looks light. And millions of these sarcomeres lined up give the fiber its striped coat. Contraction happens when myosin heads reach out, grab the actin filaments, and pull them inward like hands hauling on a rope. As every sarcomer shortens at once, the whole fiber and the whole muscle shorten, producing the pull that moves a bone. Each cycle of grabbing and pulling costs ATP and needs calcium, and when those run low during hard effort, the muscle fatigues. Remember, the stripes are the filaments slide, and that sliding is contraction itself, a sign the muscle is skeletal or cardiac, not smooth. Question 14. After standing outside in the cold, a person begins to shiver. Shivering is rapid involuntary muscle contraction. Which of the 4 functions of the muscular system does shivering demonstrate? Your options are A. Posture, B. Joint stability, C. Heat production, D. Mineral storage. Which would you go with? Lock it in before the reveal. The correct answer is C. Heat production. C is correct because muscle contraction generates heat as a byproduct, and shivering is rapid involuntary contraction used specifically to warm the body. Heat production is one of the 4 muscular functions. A is wrong because posture is the steady low-level contraction that holds the body upright, not the shivering response to cold. B is wrong because joint stability is the support muscles give to the joints they cross, not a way of generating warmth. D is wrong because mineral storage is a function of the skeletal system and is not one of the 4 muscular functions. The muscular system is usually reduced to one word, movement, but it actually performs 4 distinct jobs, and 3 of them are working right now, even if you're sitting still. The complete set is movement, posture, joint stability, and heat production. Movement is the obvious one, muscles pulling bones, pushing food, and driving blood. But posture keeps you upright without any felt effort. Joint stability braces your knees and shoulders to protect the ligaments. And heat production turns contraction energy into warmth, which is exactly what shivering puts to deliberate use. Around a joint like the knee, muscles cross over bone and ligament, and their steady tension helps hold everything in alignment, sharing the stabilizing load so the ligaments aren't carrying every stress alone. The common trap is borrowing functions from the wrong system. Storing minerals and producing blood cells belong to the skeletal system, not the muscular one, even though bone and muscle work side by side. So whenever a question mentions shivering, holding a posture, bracing a joint, or generating warmth, it's pointing straight at one of these 4 muscular functions. Question 15. A person deliberately smiles and then shifts their gaze to follow a moving object. The muscle type producing these voluntary facial and eye movements is also responsible for moving the bones. What muscle type is this? Your options are A. Skeletal muscle, B. Smooth muscle, C. Cardiac muscle, D. Visceral muscle. Don't overthink it. Which one feels right? The correct answer is A, skeletal muscle. A is correct because skeletal muscle, also called striated muscle, is under voluntary control and moves the bones while also controlling facial expressions and eye movements. B is wrong because smooth muscle works involuntarily in the walls of internal organs and does not produce voluntary facial movement. C is wrong because cardiac muscle is found only in the heart and cannot be consciously controlled. D is wrong because visceral muscle is another name for smooth muscle, which is involuntary and does not move the eyes or face on command. Skeletal muscle, also called striated muscle, is the tissue you consciously control. It moves the bones of your body and gives you the power to walk, lift, throw, and write. Its reach goes far beyond big limb movements. The same tissue that powers a sprint also creates a smile, a frown, and the quick shift of your gaze, since striated and skeletal are just two names for one muscle type. Each muscle connects to bone through a tendon, the tough cord that carries the muscle's pull to the skeleton. When the muscle contracts, it tugs the tendon tugs the bone, and the bone swings around its joint. Skeletal muscle waits for a conscious signal from the brain. Unlike smooth muscle lining the organs, or cardiac muscle in the heart, both of which run automatically. Skeletal muscles also work in opposing pairs, like the muscles bending and straightening the elbow, so one relaxes precisely as the other takes over. Whenever a scenario mentions voluntary control, movement of bones, facial expression, or eye movement, it's describing skeletal muscle, no matter whether it's called striated or skeletal. Question 16. The central nervous system serves as the body's command and processing core. Which two structures make up the central nervous system? Your options are A, the heart and the lungs, B, all of the nerves outside the spinal cord, C, the cranial nerves and the sensory organs, D, the brain and the spinal cord. Got a guess? Lock it in. The correct answer is D, the brain and the spinal cord. D is correct because the central nervous system consists of exactly two structures, the brain and the spinal cord, which together form the command and processing core. A is wrong because the heart and lungs are organs of other systems and are not part of the nervous system at all. B is wrong because all of the nerves outside the brain and spinal cord make up the peripheral nervous system, not the central nervous system. C is wrong because cranial nerves and sensory organs belong to the peripheral nervous system that feeds information into the central nervous system. The nervous system has two great divisions, and the central nervous system is the command core. It consists of exactly two structures, the brain and the spinal cord, and nothing else belongs to it. The spinal cord runs down the back inside the protective vertebral column, carrying signals in both directions between the body and the brain. Because this tissue is so vital and barely regenerates, the skull encases the brain and the vertebral column encases the spinal cord along its whole length. The brain sits atop the spinal cord highway, organized into regions with different jobs. The largest region handles conscious thought, language, memory, and voluntary movement. Another near the back coordinates balance and fine motor control, and a lower region manages automatic life support like breathing, heart rate, and digestion. The point tested most often is exact membership. The central nervous system is only the brain and spinal cord, full stop. The moment a nerve leaves the brain or spinal cord, it crosses into the peripheral nervous system. So remember, central means midline structures, while everything branching outward is peripheral. The central nervous system is the processing core, the brain and spinal cord, where signals are interpreted and decisions made, while the peripheral nervous system is the vast network reaching everywhere else. Question 17. a neurologist explains that one division of the nervous system includes every nerve lying outside the brain and spinal cord, relaying messages to the limbs and internal organs. Which division is being described? Your options are A. The central nervous system, B. The peripheral nervous system, C. The skeletal system, D. The integumentary system. Which one is it? Pause the video if you need more time. The correct answer is B. The peripheral nervous system. B is correct because the peripheral nervous system is made up of all the nerves outside the brain and spinal cord, carrying messages between the central nervous system and the rest of the body. A is wrong because the central nervous system is the brain and spinal cord themselves, not the outlying nerves. C is wrong because the skeletal system is made of bones and connective tissue and is not a division of the nervous system. D is wrong because the integumentary system is the skin, hair, and nails, which is unrelated to the divisions of the nervous system. The peripheral nervous system is everything outside the brain and spinal cord, the sprawling network of nerves branching out to reach the rest of the body. If the central nervous system is headquarters, this is the field network connecting headquarters to everywhere else. Its core job is relaying messages in both directions. Sensory information travels inward from skin, muscles, and organs toward the brain and spinal cord, while motor commands travel outward to muscles and glands. The peripheral system splits into branches with different duties. The somatic branch carries voluntary commands to skeletal muscles, while the autonomic branch quietly runs involuntary functions like heart rate and digestion, splitting further into a sympathetic part that revs the body up and a parasympathetic part that calms it down. Peripheral nerves also keep the head sense organs in touch with the brain. The eyes, ears, nose, and mouth all feed sight, sound, smell, and taste into the brain through peripheral nerves dedicated to the head and face. In peripheral neuropathy, damaged nerves at the hands and feet cause numbness and weakness at the body's edges, far from the protected brain and spinal cord. Keep the contrast clear. The central nervous system processes signals, while the peripheral nervous system is the outer web that carries them to and from everywhere else. Question 18. Sensitive cells in the eyes, ears, nose, and mouth detect light, sound, and other stimuli. Through which structures is the sensory information carried directly to the brain? Your options are A. The spinal cord, B. The digestive, C. The cranial nerves, D. The sympathetic nerves. Take a second. Which answer would you pick? The correct answer is C. The cranial nerves. C is correct because sensory information from the eyes, ears, nose, and mouth travels to the brain through the cranial nerves, which emerge directly from the brain to serve the head and face. It is wrong because the spinal cord carries signals from the trunk and limbs, but the sense organs of the head connect through the cranial nerves. B is wrong because the aorta is the largest artery and carries blood, not sensory signals. D is wrong because the sympathetic nerves drive the fight or flight response and do not carry vision, hearing, taste, and smell to the brain. The eyes, ears, nose, and mouth are the brain's windows to the outside world, each packed with specialized cells tuned to a particular stimulus. But capturing a sensation is only step one. That information still has to travel to the brain to be understood. Cells in the eye react to light. Cells in the ear react to sound waves and movement. Cells in the nose react to airborne chemicals. And cells in the mouth react to dissolved chemicals in food. Each of these specialized cells turns raw stimuli into nerve signals. The cranial nerves are 12 pairs that emerge directly from the brain rather than the spinal cord, serving the head, face, and certain internal organs. They skip the spinal cord entirely, plugging straight into the brain for the shortest possible route. The sense organ gathers, the cranial nerve carries, and the brain interprets, turning nerve impulses into a recognizable image, sound, scent, or flavor. This direct line means a spinal cord injury low in the back never blinds a person or removes their sense of smell. Whenever a question lists the head's sense organs and asks how their signals reach the brain, the answer is the cranial nerves, the direct, dedicated route that never touches the spinal cord. Question 19. The nervous system is one of the most complex systems in the body. Roughly how many nerve cells operate constantly throughout the body? Your options are A. 100 billion, B. 1 million, C. 500,000, D. 10 trillion. Before I reveal it, which one do you think is right? The correct answer is A. 100 billion. A is correct because the material states that more than 100 billion nerve cells operate constantly all over the body to coordinate its activities. B is wrong because 1 million greatly understates the number of nerve cells working in the body. C is wrong because 500,000 is far too few to coordinate the body's voluntary and involuntary activity. D is wrong because 10 trillion overstates the count. The figure given is in the billions, not the trillions. The neuron is the basic functional unit of the nervous system, the individual nerve cell the entire network is built on. With more than 100 billion of these cells, the body coordinates everything it does, both consciously and unconsciously, without pause. A neuron is built for receiving, carrying, and passing along signals. The cell body keeps the cell alive. Dendrites receive incoming signals. The axon carries the signal onward, and the myelin sheath insulates the axon to speed transmission, ending at the synapse where the message passes to the next cell. Myelin dramatically speeds the nerve impulse racing down the axon, which is why it matters so much for quick reflexes and rapid coordination. In multiple sclerosis, the immune system strips this insulation away, and the bare axons conduct signals poorly, causing loss of coordination, muscle weakness, and disturbed sensation. It helps to keep the words straight. A neuron is the single cell, the functional unit, while a nerve is a bundle of these cells carrying impulses between body parts. The fact most often tested is the sheer count. More than 100 billion nerve cells, sitting in the billions, not millions or trillions. Picture one neuron as one link and the nervous system as 100 billion of those links wired together. Each cell receives at its dendrites, carries along its axon, and passes the message across a synapse, repeated billions of times to run the whole communicating network of the body. Question 20. A person touches a hot stove and jerks their hand away before they consciously feel the pain. This rapid protective response, processed largely in the spinal cord, is best explained by what? Your options are A. The endocrine feedback loop, B. Voluntary motor planning in the cerebrum, C. Gas exchange in the alveoli, D. A reflex arc. What's your answer? Commit to one before I continue. The correct answer is D. A reflex arc. D is correct because a reflex arc is the shortest nerve pathway, processed in the spinal cord, that triggers a protective movement before the signal even reaches the brain for conscious awareness. A is wrong because endocrine feedback relies on slow hormone signaling, far too slow to pull a hand from a stove in an instant. B is wrong because conscious motor planning in the cerebrum is slower than the reflex. The hand moves before the person is aware of the pain. C is wrong because gas exchange in the alveoli is a respiratory process and has nothing to do with the withdrawal reflex. A reflex arc is the nervous system at its fastest, the shortest path from stimulus to protective response. Touch a hot stove and your hand yanks back before the pain even registers. That speed comes from skipping the brain and handling the response right at the spinal cord. The hot stove shows the order perfectly. The fingertip touches the burner, the arm yanks back almost instantly, and only a fraction of a second later does the burning pain arrive in awareness. Action first, awareness second is the signature of a reflex. The reflex arc is built from 5 components in sequence. A receptor detects the stimulus, a sensory neuron carries the signal toward the spinal cord, an integration center processes it, a motor neuron carries the command back out, and an effector muscle produces the movement. The key is where the decision gets made, because the integration center sits in the spinal cord instead of the brain. The signal never has to travel all the way up and back, so the body buys precious time and limits damage before pain is ever felt. Doctors even test this directly, tapping the knee to trigger a reflex kick through specific spinal segments, checking that the arc is healthy. Remember, a reflex is instant, automatic, and spinal, not a conscious decision and not a slow hormonal response. Question 21. Breathing happens automatically because it is vital to life. About how many times does the average person breathe in a single day? Your options are 2,000, B 20,000, C 200,000, D 500. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is B, 20,000. B is correct because the average person breathes about 20,000 times each day, driven automatically by the respiratory system. A is wrong because 2,000 is far too low. The body takes that many breaths in only a couple of hours. C is wrong because 200,000 overstates the daily total roughly tenfold. D is wrong because 500 breaths would not supply nearly enough oxygen for a full day. Breathing is so vital that the body never leaves it to memory, about 20,000 times a day, and roughly 600 million times by age 70. We breathe without a single thought. The respiratory system is built from cooperating parts. The lungs where gas exchange happens, the airways that carry air in and out, the blood vessels that pick up and drop off gases, and the muscles that drive the bellows action of breathing. The lungs aren't identical. The right lung has 3 lobes, while the left has only 2, leaving room for the heart, which sits slightly to the left. That small asymmetry reflects how snugly the chest's organs are packed around the body's central pump. Breathing runs on autopilot because a control center in the brain stem watches carbon dioxide, not oxygen, as many assume. When carbon dioxide rises, like during exercise, the brain stem speeds up breathing to blow it off and pull in more oxygen. The respiratory system is a partnership of lungs, airways, vessels, and muscles, trading oxygen for carbon dioxide 20,000 times a day, all under automatic control, and always working hand in hand with the heart and blood. Question 22. Oxygen passes from inhaled air into the blood, and carbon dioxide passes from the blood into the air to be exhaled. In which structures of the lungs does this gas exchange take place? Your options are A, the bronchi, B, the trachea, C, the alveoli, D, the pharynx. Which would you go with? Lock it in before the reveal. The correct answer is C, the alveoli. C is correct because gas exchange occurs in the alveoli, the tiny air sacs at the ends of the airways, where oxygen enters the blood and carbon dioxide leaves it. A is wrong because the bronchi are large airways that carry air toward the alveoli, but are not where exchange happens. B is wrong because the trachea is the windpipe, a passage for air, not a site of gas exchange. D is wrong because the pharynx is the throat in the upper tract, and only routes air and food. Deep inside the lungs, millions of tiny air sacs called alveoli sit at the ends of the smallest airways. These are the site of gas exchange where oxygen enters the blood and carbon dioxide leaves it. Everything else in the respiratory system just delivers air to them. Each alveolus is wrapped in a fine mesh of capillaries, and both walls are only a single cell thick. That paper-thin barrier is all gas has to cross to move between air and blood. This two-way traffic runs on diffusion, gas moving from where it's crowded to where it's sparse. Oxygen drifts from the oxygen-rich air into the oxygen-poor blood, while carbon dioxide drifts the opposite way, out of the blood and into the alveolus. No energy required. A single air sac is microscopic, but millions of them together create an enormous surface, letting the lungs keep every cell supplied even during hard exertion. Pneumonia fills the alveoli with fluid so gas cannot cross, and emphysema destroys their delicate walls, both cutting oxygen delivery. The bronchi, trachea, and pharynx only carry air, they never exchange gas. Whenever a question points to the exact spot where oxygen enters the blood, it's pointing at the alveoli. Question 23. A clinician groups the nose, pharynx, and larynx together as one functional set of airways. These structures belong to which part of the respiratory system? Your options are A. The upper respiratory tract, B. The lower respiratory tract, C. The alveolar sacs, D. The pleural cavity. Don't overthink it. Which one feels right? The correct answer is A. The upper respiratory tract. A is correct because the nose, pharynx, and larynx make up the upper respiratory tract, the airways located above the windpipe. B is wrong because the lower respiratory tract is the trachea, bronchial tree, and lungs, not the nose and throat. C is wrong because the alveolar sacs sit deep within the lungs where gas exchange happens, not among the upper airways. D is wrong because the pleural cavity is the space around the lungs and is not one of the airway tracts. The airways that carry breath in and out are split into two groups, the upper respiratory tract and the lower respiratory tract. The dividing line falls at a specific, memorable point along the path of air, right at the windpipe. The upper tract is the nose, pharynx, and larynx, all sitting in the head and neck. The lower tract is the trachea, the bronchial tree, and the lungs, all located down in the chest. Follow one breath. Air enters the nose, moves through the pharynx and larynx, all upper tract, then crosses into the trachea, branches through the bronchial tree, and reaches the lungs, all lower tract. The upper tract does more than route air, it conditions it. The nose warms, moistens, and filters incoming air. The pharynx shares its passage with food, while a flap protects the airway during swallowing, and the larynx houses the vocal cords. The detail tested most often is simply which organ belongs to which tract. Just remember, the nose, pharynx, and larynx point upward, while the trachea, bronchium, and lungs point downward. Question 24. At the alveoli, which option correctly describes the direction in which the two main respiratory gases move? Your options are A. Oxygen moves from blood into the alveoli, and carbon dioxide moves from the alveoli into the blood. B. Both oxygen and carbon dioxide move from the alveoli into the blood. C. Both oxygen and carbon dioxide move from the blood into the alveoli. D. Oxygen moves from the alveoli into the blood, and carbon dioxide moves from the blood into the alveoli. Got a guess? Lock it in. The correct answer is D. Oxygen moves from the alveoli into the blood, and carbon dioxide moves from the blood into the alveoli. D is correct because oxygen moves from the alveoli into the blood, and carbon dioxide moves from the blood into the alveoli to be exhaled. This is the standard direction of gas exchange. A is wrong because this reverses both gases. Oxygen is taken into the blood and carbon dioxide is released from it, not the other way around. B is wrong because carbon dioxide must leave the blood to be exhaled, so both gases cannot move into the blood. C is wrong because oxygen must enter the blood to reach the cells, so both gases cannot move into the alveoli. At the alveoli, oxygen and carbon dioxide trade places, and the direction each one moves is fixed and worth memorizing exactly. Oxygen moves from the alveoli into the blood, while carbon dioxide moves from the blood into the alveoli. Freshly inhaled air in the alveoli is rich in oxygen and nearly empty of carbon dioxide, while arriving blood is the opposite. That steep difference across the thin alveolar wall is the engine of the exchange. Diffusion, where each gas drifts from where it's crowded to where it's sparse. Picture the alveolus wrapped by a capillary. Oxygen, crowded in the air sac, drifts across the thin wall into the blood, while carbon dioxide, crowded in the blood, drifts out into the alveolus to be exhaled. Constant breathing and blood flow keep these gradients steep, so the exchange never stalls. But the direction reverses at the tissues, where oxygen leaves the blood to enter starved cells and carbon dioxide leaves cells to enter the blood, since the blood is simply a courier, picking up gas where it's plentiful and dropping it where it's needed. The classic trap is reversing this direction, so anchor it to the body's goal, at the lungs. Oxygen flows in and carbon dioxide flows out, stocking fresh oxygen while venting waste gas. Question 25. After oxygen diffuses into the blood at the lungs, what carries that oxygen to every cell in the body? Your options are A. The lymphatic vessels, B. The cardiovascular system pumping blood, C. The nerves of the spinal cord, D. The digestive tract. Which one is it? Pause the video if you need more time. The correct answer is B. The cardiovascular system pumping blood. B is correct because the respiratory and cardiovascular systems work together. Once oxygen enters the blood at the lungs, the heart pumps that blood to deliver oxygen to every cell. A is wrong because lymphatic vessels carry lymph fluid for immune defense, not oxygen-rich blood to the cells. C is wrong because nerves carry electrical signals, not oxygen. D is wrong because the digestive tract absorbs nutrients from food but does not transport oxygen through the body. The respiratory and cardiovascular systems work as a single partnership. The lungs handle gas exchange, but only the heart and blood vessels can carry that oxygen to the rest of the body. Once oxygen diffuses into the blood at the lungs, it needs a pump to go anywhere. The heart drives that oxygen-rich blood outward under pressure, reaching every distant tissue that depends on it. Out at the tissues, the exchange reverses. Cells take oxygen from the blood and hand back carbon dioxide as waste. The blood carries that carbon dioxide back to the heart and lungs, where it is exhaled, completing the round trip. This cycle runs continuously, so if failure in one system quickly drags down the other. If the heart can't pump, the lungs congest. If the lungs can't load oxygen, the heart pumps blood that starves the tissues. Remember, transport, deliver, and pump point to the cardiovascular system, while exchange and inhale point to the respiratory system. So when a question asks what carries oxygen from the lungs to the rest of the body, the answer is the cardiovascular system, the heart and blood. Question 26. The heart is a four-chambered pump with two upper atria and two lower ventricles. Into which side of the heart does freshly oxygenated blood returning from the lungs enter? Your options are A. The right atrium, B. The right ventricle, C. The left side of the heart, D. The inferior vena cava. Take a second. Which answer would you pick? The correct answer is C, the left side of the heart. C is correct because oxygenated blood returning from the lungs enters the left side of the heart, which then pumps it out to the body through the aorta. A is wrong because the right atrium receives oxygen-poor blood coming back from the body, not oxygen-rich blood from the lungs. B is wrong because the right ventricle pumps oxygen-poor blood to the lungs. It does not receive freshly oxygenated blood. D is wrong because the inferior vena cava is a large vein returning oxygen-poor blood from the lower body to the right atrium. The heart is a muscular pump built around 4 chambers, arranged so it can handle 2 separate streams of blood without ever mixing them. The 2 upper chambers, called atria, receive incoming blood. The 2 lower chambers, called ventricles, pump that blood onward, so blood always drops from atrium to ventricle before it moves on. The right atrium receives oxygen-poor blood from the body and the right ventricle sends it to the lungs. The left atrium receives fresh, oxygen-rich blood from the lungs, and the left ventricle drives it out to the entire body. The left ventricle has the thickest, most muscular wall of the 4 chambers because it must force blood all the way through the body. The right ventricle only pushes blood the short distance to the nearby lungs, so its wall stays noticeably thinner. One-way valves snap shut between chambers to stop backflow, producing the lub-dub heartbeat sound. Keep this split clear. The left side always serves the body with oxygen-rich blood, and the right side always serves the lungs with oxygen-poor blood. Question 27. A nursing student uses the memory aid that arteries and airway both begin with the letter A. What does this aid help them remember about arteries? Your options are: A. Arteries carry blood away from the heart. B. Arteries always carry oxygen-poor blood. C. Arteries return blood to the heart. D. Arteries store urine before it is released. Before I reveal it, which one do you think is right? The correct answer is A. Arteries carry blood away from the heart. A is correct because arteries carry blood away from the heart to the body tissues, which the memory aid arteries equals away is meant to reinforce. B is wrong because most arteries carry oxygen-rich blood. The naming rule is about direction away from the heart, not oxygen content. C is wrong because returning blood toward the heart describes veins, not arteries. D is wrong because storing urine is the job of the bladder and has nothing to do with arteries. Arteries and veins are defined by one thing only: the direction blood travels relative to the heart. Arteries carry blood away from the heart and veins carry it back regardless of oxygen content. A simple memory trick locks in the direction for good. Artery and airway both start with the letter A, so an artery is always the vessel carrying blood away from the heart toward the body's tissues, the aorta. The largest artery leaves the heart and branches again and again, like the trunk of a tree splitting into smaller limbs, until vessels become microscopic inside every organ of the body. The clearest proof is the pathway to the lungs. The vessels carrying blood from the heart to the lungs are arteries, even though that blood is oxygen poor, while the return vessels are veins, even though they carry oxygen-rich blood. Whenever a scenario describes blood moving outward from the heart, or mentions the aorta and its branches, it's pointing to an artery. Direction, not oxygen, settles the matter every time. Question 28. In the tissues, oxygen and nutrients pass from the blood into the cells through vessels so small that red blood cells move through them in single file. What are these vessels? Your options are veins, B. the aorta, C. arteries, D. capillaries. What's your answer? Commit to one before I continue. The correct answer is D. Capillaries. D is correct because capillaries are the smallest blood vessels, only 1 cell thick, and they are where oxygen and nutrients pass from the blood into the surrounding cells. A is wrong because veins are larger vessels that return blood towards the heart, not the microscopic exchange vessels. B is wrong because the aorta is the largest artery in the body, the opposite of the tiniest vessels. C is wrong because arteries carry blood away from the heart, but branch into capillaries before exchange with the cells occurs. Capillaries are the smallest blood vessels in the body, so narrow that red blood cells must pass through single file. Despite being easy to overlook next to the heart and aorta, capillaries are where circulation actually accomplishes its purpose. The capillary wall is only 1 cell thick, thin enough for small molecules to slip across easily. Oxygen and nutrients pass out of the blood into the cells, while carbon dioxide and waste pass back into the blood. Arteries carry blood away from the heart, branching down until they become capillaries. After the exchange with tissue is complete, capillaries merge into veins that carry blood back to the heart, making the capillary bed the turnaround point. A thick wall like an arteries would block the easy passage of oxygen and nutrients. By trading strength for thinness, and with blood flowing slowly through narrow channels, the capillary lets exchange happen quickly across a vast area. The dense mesh of capillaries reaches nearly every cell in the body, since no cell can be served without one nearby. Remember, smallest 1 cell thick single file and exchange all point straight to capillaries. Question 29. Blood leaving the left ventricle is pumped into the largest artery in the body, which then branches to supply all the organs. What is this artery? Your options are A. The pulmonary vein, B. The aorta, C. The superior vena cava, D. A coronary capillary. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is B, the aorta. B is correct because the aorta is the largest artery in the body. It carries blood out of the left ventricle and branches into smaller arteries that reach every organ. A is wrong because the pulmonary vein returns blood from the lungs to the heart and is a vein, not the largest artery. C is wrong because the superior vena cava is a large vein that returns oxygen-poor blood from the upper body to the heart. D is wrong because a capillary is among the smallest vessels in the body, the opposite of the largest artery. The aorta is the largest artery in the body, the single vessel through which oxygen-rich blood leaves the heart. When the left ventricle contracts, it drives blood out under high pressure, making the aorta the starting point of circulation to every organ. Just as a trunk sends off limbs that divide into branches and twigs, the aorta sends off major arteries that split again and again into smaller vessels. Every artery in the body traces its origin back to this one common root. From the aorta, the path narrows in stages. Major arteries branch into smaller arteries, which continue dividing until they become capillaries. The steady narrowing carries blood from one wide channel down to the microscopic vessels where oxygen finally reaches the cells. The aorta's walls are strong yet slightly elastic, stretching with each surge from the left ventricle and recoiling between beats to smooth the flow. Because it carries blood away from the heart, it is an artery by definition, and because it carries oxygen-rich blood to the whole body, it is the most important artery in systemic circulation. Remember the aorta as the great trunk line out of the heart. The left ventricle fires oxygen-rich blood into it, and it feeds every artery in the body. The contrast with capillaries, the smallest vessels, marks the two ends of the arterial road. Question 30. A normal adult heart at rest beats a set number of times each minute, and that rate rises during exercise to deliver more oxygen. What is the normal resting adult heart rate given in the material? Your options are A. 50 beats per minute, B. 20 beats per minute, C. 72 beats per minute, D. 200 beats per minute. Which would you go with? Lock it in before the reveal. The correct answer is C. 72 beats per minute. C is correct because a normal adult heart beats about 72 times per minute at rest, with the rate rising during exercise to move more oxygen. A is wrong because 50 beats per minute is below the stated normal resting rate. B is wrong because 120 beats per minute reflects heavy exertion, not a resting rate. D is wrong because 200 beats per minute approaches a maximum effort rate and is far above resting. A healthy adult heart beats about 72 times per minute at rest. That steady number is the baseline pace of the pump, the anchor point the whole cardiovascular system works from. The faster the heart beats, the more oxygen-rich blood it moves each minute. At rest, 72 beats easily covers the body's modest needs, but that demand for oxygen is not constant. During exercise, muscles burn oxygen fast, so the heart speeds up to deliver more. This is homeostasis at work, with the nervous and endocrine systems nudging the rate up during exertion and back down once the body relaxes. The familiar lub-dub sound is the heart's valves closing as its chambers contract and relax in sequence. Each pair of sounds marks one full cycle, and counting those cycles over a minute is exactly how heart rate is measured. 72 beats per minute is the calm, healthy baseline the heart returns to between demands. It climbs with exercise or stress and eases back with rest, always tracking the body's need for oxygen. Question 31. The digestive system processes food through 4 ordered functions. Which function moves digested nutrients out of the digestive tract and into the bloodstream? Your options are A. Absorption, B. Ingestion, C. Digestion, D. Elimination. Don't overthink it. Which one feels right? The correct answer is A. Absorption. A is correct because absorption is the function that moves digested nutrients from the digestive tract into the bloodstream so the body's cells can use them. B is wrong because ingestion is taking food into the mouth, the starting point of digestion, not the move into the blood. C is wrong because digestion is the mechanical and chemical breakdown of food into smaller molecules, which comes before absorption. D is wrong because elimination is expelling undigested waste from the body, the final step rather than nutrient uptake. The digestive system exists to turn food into something the body can actually use, breaking it down and clearing away what's left. That whole journey can be organized into 4 functions occurring in sequence: ingestion, digestion, absorption, and elimination. Ingestion is simply taking food into the mouth, the starting point that gets overlooked because it seems so basic. Without it, nothing else in the sequence could ever begin. Digestion breaks food down in 2 ways at once. Mechanical digestion physically tears food apart as teeth grind and the stomach churns, while chemical digestion uses enzymes and acids to split large molecules into smaller, absorbable ones. Absorption is the bridge between the food in the tube and the cells that need it, the moment nutrients finally cross from the digestive tract into the bloodstream. Until that crossing happens, the nutrients haven't truly entered the body. Food is taken in, broken down, absorbed into the blood, and the remainder is eliminated. Each function owns its own distinct stage of the journey from mouth to waist. Question 32. A patient with damage to the finger-like villi that line one organ has trouble absorbing nutrients into the bloodstream. In which organ does most nutrient absorption normally occur? Your options are A. The stomach, B. The small intestine, C, the large intestine. D, the esophagus. Got a guess? Lock it in. The correct answer is B, the small intestine. B is correct because most nutrient absorption occurs in the small intestine, whose inner wall is lined with villi that greatly increase the surface area for absorption. It is wrong because the stomach churns food into chyme and begins protein digestion, but is not the main site of nutrient absorption. C is wrong because the large intestine mainly reclaims water and electrolytes and does not absorb significant nutrients. D is wrong because the esophagus only transports food down to the stomach and does no absorbing. The small intestine is where digestion pays off, the place where broken down nutrients finally cross into the bloodstream. Let's look at what makes this organ so good at its job. The inner wall of the small intestine is covered in countless tiny finger-like projections called villi. Each villus reaches into the passing food, turning a smooth tube into a deeply folded, fuzzy surface that dramatically multiplies the area available for absorption. Absorption happens across that surface, so the more wall touching the food, the more molecules can pass through at once, packing in that much surface, plus a length of roughly 20 feet coiled into the abdomen, gives food a long, absorbing journey. The small intestine doesn't work alone. Bile from the liver and gallbladder handles fats, while enzymes from the pancreas finish breaking down carbohydrates, proteins, and fats. This teamwork ensures nutrients are fully prepared right where absorption occurs. Celiac disease shows just how much absorption depends on the villi. An immune reaction to gluten flattens them, stripping away surface area, so nutrients pass through unclaimed even when food is plentiful. Question 33. The esophagus is a muscular tube that carries swallowed food from the throat to the stomach. Approximately how long is the esophagus? Your options are 3 to 4 inches, B 20 feet, C 1 to 2 inches, D 9 to 10 inches. Which one is it? Pause the video if you need more time. The correct answer is D, 9 to 10 inches. D is correct because the esophagus is about 9 to 10 inches long, connecting the throat to the stomach and moving food along by waves of muscle contraction. A we is wrong because 3 to 4 inches is too short to span from the throat down to the stomach. B is wrong because about 20 feet is the length of the small intestine, not the esophagus. C is wrong because 1 to 2 inches is closer to the length of the female urethra, not the esophagus. The esophagus is the muscular tube that carries swallowed food from the throat down to the stomach, measuring about 9 to 10 inches long. It bridges the gap through the chest, connecting mouth to stomach. The esophagus does not digest food, and that limitation is part of its definition. No nutrients are broken down or absorbed along its length. Food simply passes through on its way to the stomach, where the real chemical work begins. Food is pushed along by peristalsis, a series of rhythmic, wave-like contractions of smooth muscle in the esophageal wall. Each wave squeezes behind the swallowed food and relaxes ahead of it, driving the mass steadily toward the stomach, automatically and without conscious effort. Because peristalsis actively propels food, a person lying down or even upside down can still swallow successfully. The muscular waves do the work regardless of body position, proving that smooth muscle, not gravity, carries food along its journey. Picture the esophagus as a moving conveyor belt rather than a processing station, delivering a swallow to the stomach 9 to 10 inches later by waves of peristalsis. Transport, peristalsis, and the throat-to-stomach connection all point to this tube that moves food without digesting it. Question 34. A patient has their gallbladder removed and is told they can still digest fats, although less efficiently after large fatty meals. What does this reveal about the gallbladder's role? Your options are A. The gallbladder produces bile, so removing it stops bile production. B. The gallbladder produces the insulin needed for fat digestion. C. The gallbladder stores bile while the liver still produces and secretes it. D. The gallbladder absorbs fats directly from the small intestine. Take a second. Which answer would you pick? The correct answer is C. The gallbladder stores bile while the liver still produces and secretes it. C is correct because the gallbladder stores and concentrates bile, but the liver is what produces it. After removal, the liver still makes bile and secretes it into the small intestine, so fat digestion continues, just less efficiently. A is wrong because the liver, not the gallbladder, produces bile, so removing the gallbladder does not stop bile production. B is wrong because insulin is produced by the pancreas and regulates blood glucose, not fat digestion in the gallbladder. D is wrong because the gallbladder does not absorb fats. Absorption occurs across the wall of the small intestine. The liver and gallbladder are a team, and the cleanest way to keep them straight is one simple rule. The liver produces bile, while the gallbladder only stores it. Bile is a yellow-green fluid the liver makes continuously. It attacks large globules of fat and breaks them into smaller droplets that digestive enzymes can handle, which is exactly what makes dietary fat usable to the body. The liver continuously produces bile, the gallbladder stores and concentrates it, and when a fatty meal arrives, the gallbladder contracts and delivers a concentrated dose straight into the small intestine. When the gallbladder is removed, storage is lost, but the liver keeps producing bile and secretes it directly into the small intestine. Digestion continues just less efficiently, especially after a large fatty meal. The liver produces bile, the gallbladder stores it, and confusing the two is the classic error. Gallstones blocking that path show just how much the whole system depends on this partnership. Question 35. The pancreas is an accessory digestive organ that also secretes a hormone regulating blood glucose. Which hormone does the pancreas produce? Your options are insulin, B. bile, C. keratin, D. estrogen. Before I reveal it, which one do you think is right? The correct answer is A. Insulin. A is correct because the pancreas secretes insulin, a hormone that signals cells to take up glucose and lowers blood glucose, linking the digestive and endocrine systems. B is wrong because bile is a digestive fluid produced by the liver, not a hormone made by the pancreas. C is wrong because keratin is a structural protein found in hair and nails, not a pancreatic hormone. D is wrong because estrogen is a female sex hormone produced by the ovaries, not by the pancreas. The pancreas is one of the clearest bridges between two major body systems, serving both digestion and hormone regulation at the same time. It quietly works behind the stomach, handling two very different jobs with one organ. As a digestive organ, the pancreas releases enzymes into the small intestine that break down carbohydrates, proteins, and fats. As an endocrine gland, it releases hormones straight into the bloodstream, the hallmark of endocrine signaling, rather than into the digestive tract. Insulin is the hormone most worth knowing. When blood glucose rises after a meal, the pancreas senses it and releases insulin, signaling cells to pull glucose out of the blood, so the level falls back toward normal. Insulin and glucagon push blood glucose in opposite directions, keeping it within a safe range. When the pancreas can't produce enough insulin, or cells stop responding to it, glucose builds up in the blood and diabetes mellitus results. The pancreas produces insulin and bridges digestion with hormone control, so whenever a question pairs digestive enzymes with blood glucose regulation, The answer is the pancreas. Question 36. The major organs of the urinary system filter waste products such as urea from the blood and produce urine. Which organs perform this filtering? Your options are A. The ureters, B. The kidneys, C. The bladder, D. The urethra. What's your answer? Commit to one before I continue. The correct answer is B. The kidneys. B is correct because the kidneys are the major organs of the urinary system. They filter waste products such as urea from the blood and produce urine. A is wrong because the ureters are muscular tubes that carry urine from the kidneys to the bladder. They do not filter blood. C is wrong because the bladder stores urine until it is released and does no filtering. D is wrong because the urethra carries urine out of the body and performs no filtration. The kidneys are the body's blood filtering organs, constantly clearing away waste before it can build up to dangerous levels. The chief waste is urea from broken down proteins. Alongside it, the kidneys clear uric acid from genetic material, creatinine from muscle activity, and excess water and salts, concentrating all of it into urine. The actual filtering happens in nephrons, tiny filtering units numbering roughly 1 million per kidney, each pulling waste from the blood, reclaiming what's useful, and sending the rest onward as urine. Beyond filtering, the kidneys help regulate blood pressure through hormones and fluid balance, and they stimulate red blood cell production by signaling the bone marrow, extending their reach into circulation and oxygen supply. Diseases like diabetes and high blood pressure can damage this filtering system, letting waste build up in the blood, which is exactly why the kidney's role as the body's filter is so vital. Question 37. Among the 4 urinary organs, only one can hold urine until the body is ready to release it. Which organ stores urine? Your options are A. The kidney, B. The ureter, C. The urethra, D. The bladder. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is D. The bladder. D is correct because only the bladder stores urine. It is a muscular, hollow organ that expands as it fills and holds urine until release. A is wrong because the kidney produces urine by filtering blood but does not store it. B is wrong because the ureter is a transport tube carrying urine from the kidney to the bladder, not a storage organ. C is wrong because the urethra is the exit passage for urine and does not store it. The bladder is the body's holding tank for urine, the only organ in the urinary system built to store it until the body is ready for release. The kidneys make urine steadily, so the bladder collects it between bathroom trips. Urine travels from the kidneys down the ureters into the bladder and finally out through the urethra. The bladder sits in the middle of this pathway, a muscular sac whose stretchy walls expand to hold urine and relax back down once it's emptied. Only the bladder actually stores urine in reserve. The kidneys filter and pass it along. The ureters just transport it, and the urethra only conducts it outward, so the bladder alone fits any description of a storage organ. As the bladder fills, stretching walls send a signal. Once it holds roughly 300 to 400 milliliters, you feel the urge to urinate, a warning system that grows stronger the fuller it gets. So when a question asks which organ stores urine until release, the answer is the bladder alone, the muscular reservoir between the tubes that bring urine in and the tube that lets it out. Question 38. Urinary tract infections are far more common in females than in males. Which anatomical fact best explains this difference? Your options are A. The female bladder cannot store as much urine. B. Females have only one kidney. C. The female urethra is much shorter, about 1 to 2 inches, than the male urethra. D. Females do not have ureters. Which would you go with? Lock it in before the reveal. The correct answer is C. The female urethra is much shorter, about 1 to 2 inches than the male urethra. C is correct because the female urethra is only about 1 to 2 inches long, while the male urethra is roughly 8 inches. So bacteria have a much shorter path to the female bladder, making infections more common. A is wrong because bladder storage capacity does not explain the higher infection rate. The difference in urethra length does. B is wrong because females have 2 kidneys just as males do, so this is not a real anatomical difference. D is wrong because both males and females have ureters connecting each kidney to the bladder. The urethra carries urine out of the body, but its length is not the same in everyone. That one difference between males and females turns out to explain a major pattern in health. In females, the urethra is short, just 1 to 2 inches, a direct path from the bladder to the outside. In males, it stretches roughly 8 inches, traveling through the prostate gland and down the length of the penis. The female urethra handles only urine, keeping it short and simple. The male urethra does double duty, passing through the prostate gland and serving as a shared channel for both urine and semen. The shorter the passage, the easier it is for bacteria to travel upward into the bladder. That is exactly why urinary tract infections are far more common in females than in males. Pair each length with its consequence. 1 to 2 inches and higher infection risk for females, 8 inches and a longer defense for males. That simple measurement is the key to understanding the pattern. Question 39. While filtering the blood, the kidneys return useful substances such as glucose, water, and salts to the bloodstream rather than losing them in urine. What is this process called? Your options are A. Reabsorption, B. Ingestion, C. Inflammation, D. Ventilation. Don't overthink it. Which one feels right? The correct answer is A. Reabsorption. A is correct because reabsorption is the process by which the kidneys return needed substances such as glucose, water, and salts to the bloodstream after filtration. B is wrong because ingestion is taking food into the mouth, a digestive function, not a kidney process. C is wrong because inflammation is an immune response involving swelling and redness, unrelated to kidney filtering. D is wrong because ventilation is the movement of air in and out of the lungs, a respiratory process. Filtering the blood is deliberately messy. Retia pulls out water, salts, glucose, and waste altogether. Reabsorption is the kidney's fix, reclaiming the useful substances and returning them to the blood. So only true waste leaves as urine. The kidneys prioritize reclaiming glucose, the body's fuel, water, to prevent dehydration, and salts and electrolytes, to keep blood chemistry balanced. These were all filtered out with the wastes, but reabsorption rescues them and sends them back into circulation. Inside the nephron, filtrate travels through a long, winding tubule. Along the way, glucose, water, and salts are pulled back through the tubule wall into nearby blood vessels, while whatever remains continues on to become concentrated urine. Hormones fine-tune this process moment to moment. One signals the tubules to reabsorb more water during dehydration, concentrating the urine, while another boosts sodium reabsorption, and water follows, raising blood pressure. When glucose overwhelms the kidney's capacity to reclaim it, it spills into urine, a warning sign of uncontrolled diabetes. Whenever you see the kidneys reclaiming glucose, water, or salts back into the blood, that's reabsorption at work. Question 40. The kidneys are bean-shaped organs, each about the size of a fist and cushioned by surrounding fat. Where in the body are they located? Your options are A. In the chest cavity beside the heart. B. In the abdominal cavity on either side of the spine. C. Inside the pelvis below the bladder. D. Attached beneath the liver. Got a guess? Lock it in. The correct answer is B. In the abdominal cavity on either side of the spine. B is correct because the kidneys sit in the abdominal cavity on either side of the spine, toward the back, where a layer of fat protects them from impact. A is wrong because the kidneys are not in the chest cavity. The heart and lungs occupy that space. C is wrong because the kidneys sit higher than the bladder. In males, the prostate, not a kidney, lies below the bladder. D is wrong because the kidneys are not attached beneath the liver. The gallbladder is the organ tucked under the liver. Let's fix the kidneys' true location in your mind, because it explains their protection, their neighbors, and why back injuries put them at risk. The kidneys are bean-shaped, fist-sized organs tucked behind the abdominal cavity, one on either side of the spine, cushioned by a layer of protective fat, with an adrenal gland perched on top of each one. Because the kidneys sit so close to the back surface, that fatty cushion is their main shield, which is exactly why football pads extend above the waistband, right over the kidneys. Traps often place the kidneys in the chest beside the heart, in the pelvis below the bladder, or tucked beneath the liver, but the real answer is the back of the abdominal cavity, flanking the spine. Whenever a question describes bean-shaped, fist-sized filtering organs protected by fat, think abdominal cavity, either side of the spine. Question 41. The immune system produces, stores, and carries cells that find and destroy bacteria, viruses, and other foreign invaders. What are these defensive cells called? Your options are A. Red blood cells, B. Platelets, C. Neurons, D. White blood cells, also called leukocytes. Which one is it? Pause the video if you need more time. The correct answer is D. White blood cells, also called leukocytes. D is correct because white blood cells, also called leukocytes, are the defensive cells the immune system produces, stores, and carries to find and destroy invaders. A is wrong because red blood cells carry oxygen through the body. They do not seek out and destroy pathogens. B is wrong because platelets help blood clot at wound sites. They are not the body's infection-fighting cells. C is wrong because neurons are nerve cells that transmit electrical signals and have no role in immune defense. The immune system is the body's defense network, and at its center are white blood cells, also called leukocytes. These cells are produced, stored, and dispatched throughout the body to find and destroy anything that threatens health. White blood cells are hunters, seeking out bacteria, viruses, parasites, and fungi, along with any foreign, harmful substance. Wherever invaders breach the body's barriers, leukocytes move in to confront them, making them the frontline soldiers of immunity. The ways leukocytes deal with threats vary. Some engulf and digest invaders whole. Others release chemicals that damage or mark pathogens, and still others coordinate the wider response. But the goal is always to neutralize the threat before it spreads. Picture a leukocyte surrounding a bacterium, its membrane wrapping around the invader and pulling it inside a digestive vacuole, where it's broken down and cleared away. One of several methods these cells use to protect the body. When a question mentions defense, destroying pathogens, or leukocytes, it's pointing to white blood cells, not red blood cells, platelets, or neurons. They are the essential defenders standing between the body and disease. Question 42. On the surface of a virus is a molecular marker that the immune system recognizes as foreign, triggering a defensive response. What is this marker called? Your options are A, an antibody, B, a hormone, C, an antigen, D, a platelet. Take a second. Which answer would you pick? The correct answer is C, an antigen. C is correct because an antigen is the molecular marker on the surface of a foreign invader that the immune system recognizes as not belonging to the body, triggering a response. A is wrong because an antibody is the protein the body makes to bind an antigen. It is the response, not the marker on the invader. B is wrong because a hormone is a chemical messenger from an endocrine gland, not a marker on a pathogen. D is wrong because a platelet is a blood component involved in clotting, not a recognition marker on a virus. Every pathogen carries a molecular marker on its surface called an antigen, and this marker is what tells the immune system that something foreign has arrived. Picture a virus studded with these markers on its outer coat. Immune cells patrol the body reading these surface markers, and the moment one is recognized as foreign, it triggers the entire defense response. It's crucial not to confuse the two. The antigen is the foreign marker itself, while the antibody is the protein the body builds afterward to bind and tag that marker for destruction. This is why colds keep coming back. Each version of the virus carries a slightly different antigen, so the immune memory built against one strain doesn't match the next, forcing a fresh response every time. So keep it simple. The antigen is the flag on the invader that gets recognized as foreign, not the antibody the body produces in response. Vaccines even use this by introducing a harmless antigen so the body learns to recognize it in advance. Question 43. A person with the flu has a swollen, red, painful throat along with a fever. These four signs, swelling, redness, pain, and elevated temperature, are the classic markers of what? Your options are A, the inflammatory response, B, reabsorption, C, vasoconstriction, D, ovulation. Before I reveal it, which one do you think is right? The correct answer is A, the inflammatory response. A is correct because swelling, redness, pain, and elevated temperature are the four classic signs of the inflammatory response, the immune system's frontline reaction to a recognized invader. B is wrong because reabsorption is a kidney process that returns useful substances to the blood, not an immune reaction. C is wrong because vasoconstriction is the narrowing of blood vessels to conserve heat, not the cluster of inflammation signs. D is wrong because ovulation is the release of an egg from the ovary and has nothing to do with the immune response. When the immune system detects an invader, one of its earliest reactions is inflammation, a frontline defense that springs into action right at the site of trouble to contain and attack the threat. Inflammation is marked by four classic signs that appear together: swelling, pain, redness, and elevated temperature, felt as warmth or fever. These four signs are so characteristic they're called the cardinal signs of inflammation, the fingerprint of the response. These signs trace back to changes in blood flow. Vessels widen and become leaky, bringing extra blood that causes redness and warmth, while fluid and immune cells flood the tissue causing swelling, and release chemicals irritate nerve endings causing pain. Inflammation belongs to innate immunity, the fast, general arm of defense that reacts the same way regardless of the invader, buying time while the slower, specific immune response gears up. This same mechanism can misfire in allergies, triggering inflammation against harmless things like pollen or pet dander. Whenever a scenario describes swelling, pain, redness, and elevated temperature together, it's pointing straight at the inflammatory response, not reabsorption, vasoconstriction, or ovulation. Question 44. Among the immune structures, One organ in the upper chest behind the breastbone is the site where T lymphocytes mature. Which organ is this? Your options are A, the spleen, B, the thymus, C, the tonsils, D, the lymph nodes. What's your answer? Commit to one before I continue. The correct answer is B, the thymus. B is correct because the thymus, located in the upper chest behind the breastbone, is the site where T lymphocytes mature, and it is most active during childhood. A is wrong because the spleen filters blood and stores red blood cells, but is not where T cells mature. C is wrong because the tonsils are a first line of defense at the back of the throat, not a site of T cell maturation. D is wrong because lymph nodes filter lymph and house immune cells, but they do not mature T lymphocytes. The thymus is an organ tucked in the upper chest, behind the breastbone, with one very specific job, maturing white blood cells called T lymphocytes, or T cells. Picture the thymus as a training ground sitting just behind the breastbone, where immature T cells enter and emerge as fully functional defenders capable of recognizing and fighting invaders. Unusually, the thymus is most active in childhood, working hard to mature a large population of T cells that will defend the body for decades. Then it gradually shrinks with age. Its essential work largely done. The thymus is one of 7 immune structures, alongside lymph nodes, the spleen, bone marrow, the tonsils, and the adenoids, but only the thymus specializes in maturing T cells, while the spleen filters blood, lymph nodes filter lymph, and bone marrow manufactures blood cells. Also acting as an endocrine gland producing hormones, the thymus bridges 2 body systems, but the test point remains simple: T cell maturation, upper chest, behind the breastbone, always points to the thymus. Question 45. The skin contains glands that release an oily substance, keeping the skin surface from drying out and cracking. What is this oily secretion called? Your options are A, sweat, B, bile, C, insulin, D, sebum. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is D, sebum. D is correct because sebum is the oily secretion from the sebaceous glands that protects the surface of the skin so it does not dry out and crack. A is wrong because sweat is a watery secretion that cools the body through evaporation, not an oily one that prevents drying. B is wrong because bile is a digestive fluid produced by the liver, not a secretion of the skin. C is wrong because insulin is a hormone from the pancreas that regulates blood glucose, not an oily skin secretion. The skin relies on 2 key secretions to stay healthy: sebum, an oily substance, and sweat, a watery one. Let's look closer at what sebum actually does and how it fits into the bigger picture of skin function. Sebaceous glands sit near hair follicles and release sebum directly onto the skin's surface, coating it in a thin, oily film. This film keeps the skin supple, preventing the cracking and flaking that come from dryness, and even offers mild antimicrobial protection against bacteria. Sebum and sweat are easy to mix up, but they work in opposite ways. Sebum is oily and seals in moisture to stop the skin from drying out, while sweat is watery and cools the body as it evaporates, releasing heat rather than sealing anything in. Sebum and sweat are part of the larger integumentary system, which includes the skin, hair, and nails. Together, this system protects deeper tissues, senses the environment through nerve endings, lubricates the surface, and regulates temperature, with sebum and sweat covering the lubrication and temperature jobs. When a sebaceous gland gets blocked, that same protective oil backs up and can cause acne, linking the oil directly to the blemish. So whenever you see oily, sebaceous gland or prevents drying, think sebum, not sweat, bile or insulin. Question 46. The endocrine system is a signaling system like the nervous system, but instead of electrical impulses, it sends chemical messengers through the bloodstream. What are these chemical messengers called? Your options are A. Electrical nerve impulses, B. Antibodies, C. Hormones, D. Digestive enzymes. Which would you go with? Lock it in before the reveal. The correct answer is C. Hormones. C is correct because the endocrine system sends chemical messengers called hormones through the bloodstream to influence growth, development, and metabolism. A is wrong because electrical impulses are how the nervous system signals. The endocrine system uses chemical hormones instead. B is wrong because antibodies are immune proteins that bind antigens, not endocrine signaling molecules. D is wrong because digestive enzymes break down food in the digestive tract and are not the endocrine system's messengers. The endocrine system is a signaling network, just like the nervous system, but instead of firing electrical impulses, it sends chemical messengers called hormones through the bloodstream to influence activities all over the body. The nervous system uses fast electrical impulses that hit specific targets but fade quickly. The endocrine system uses slower chemical hormones that take longer to act but last far longer and spread wider through the blood. Speed versus staying power separates the two. A hormone doesn't affect every cell it passes, only cells with the matching receptor, a protein built to recognize it. When the hormone binds its receptor, it triggers a response, while cells without that receptor ignore it entirely. Hormones shape the body's most fundamental processes: growth, development including sexual maturation, and energy-related activities like metabolism, blood glucose, and the stress response. All of this works toward homeostasis, using feedback loops where rising hormone levels suppress their own release to keep the body balanced. When a question contrasts electrical nerve impulses with a slower, bloodstream-based signal reaching a target organ, it's pointing to hormones, not antibodies, not digestive enzymes, but the endocrine system's chemical messengers. Question 47. One endocrine gland sits in the front of the neck and produces hormones that regulate the body's metabolism. Which gland is this? Your options are A. The thyroid, B. The kidney, C. The gallbladder, D. The spleen. Don't overthink it. Which one feels right? The correct answer is A. The thyroid. A is correct because the thyroid, located in the front of the neck, produces thyroid hormones that regulate the body's metabolism, growth, and temperature. B is wrong because the kidney filters blood and makes urine. It is a urinary organ, not the gland that regulates metabolism. C is wrong because the gallbladder stores bile for fat digestion and is not an endocrine gland. D is wrong because the spleen filters blood and supports immunity but does not regulate metabolism. The thyroid is an endocrine gland sitting at the front of the neck, just below the voice box, and its central job is regulating metabolism. Think of it as a throttle controlling the pace at which the body burns energy. Thyroid hormones do more than manage energy use alone. They regulate metabolism, support normal growth, and help control body temperature, influencing nearly every tissue in the body. Positioned in this accessible spot at the front of the throat, the thyroid releases hormones directly into the bloodstream, which then travel to affect tissues throughout the body. A well-functioning thyroid keeps metabolism humming at a healthy rate. Too much hormone and the body races, burning energy too fast, too little, and it slows, conserving energy and cooling down. unlike the kidney, gallbladder, or spleen, which serve entirely different systems. The thyroid alone sets the body's metabolic pace. Front of the neck, thyroid hormones and metabolism are the words that point straight to this gland. Question 48. The menstrual cycle lasts about 28 days. Around which days does ovulation occur? When a mature egg is released from the ovary and a woman is most fertile? Your options are A. Days 1 to 2, B. Days 13 or 40s, C. Days 26 to 28, D. Days 20 to 22. Got a guess? Lock it in. The correct answer is B. Days 13 to 14. B is correct because ovulation occurs around days 13 to 14 of the roughly 28-day cycle, when a mature egg is released and a woman is most fertile. A is wrong because days 1 to 2 fall during menstruation, when the uterine lining sheds, not when the egg is released. C is wrong because days 26 to 28 are the end of the cycle, well after ovulation has occurred. D is wrong because days 20 to 22 fall in the luteal phase after the egg has already been released. The menstrual cycle is a roughly 28-day sequence of hormonal changes that prepares the body for possible pregnancy each month, moving through distinct phases rather than happening all at once. The cycle opens with menstruation, the shedding of the uterine lining, then a follicle matures as hormones build, leading up to ovulation near the midpoint of the cycle. Ovulation, the release of a mature egg from the ovary, occurs around day 13 or 14 of the cycle, marking the window of peak fertility since the egg can only be fertilized for a short time afterward. If fertilization doesn't happen, hormone levels drop and the uterine lining sheds as menstruation, restarting the cycle. But if the egg is fertilized, it implants in the lining. The body keeps that lining instead of shedding it, and the cycle is suppressed for the duration of pregnancy. Whenever a question mentions ovulation, being most fertile, or the release of the egg, it's pointing to that midpoint around day 13 or 14 of the cycle. Question 49. During reproduction, a sperm cell penetrates an egg to begin a pregnancy. In which structure of the female reproductive system does this fertilization normally occur? Your options are A. The uterus, B. The cervix, C. The vagina, D. The fallopian tube. Which one is it? Pause the video if you need more time. The correct answer is D. The fallopian tube. D is correct because fertilization normally occurs in the fallopian tube, where a sperm cell penetrates the egg before the fertilized egg travels to the uterus to implant. A is wrong because the uterus is where the fertilized egg implants and the fetus develops, but not where fertilization itself takes place. B is wrong because the cervix is the narrow lower end of the uterus that opens during childbirth. It is not the site of fertilization. C is wrong because the vagina is the birth canal and passage to the outside. The egg and sperm meet higher up, in the fallopian tube. Fertilization is the moment a sperm cell penetrates an egg, and it happens neither in the ovary nor in the uterus. It happens in the fallopian tube, the passage connecting the two. Sperm travel up into the fallopian tube to meet an egg released during ovulation, and there a single sperm penetrates it, forming the first cell of a new individual. That fertilized egg then journeys down the tube to the uterus, where it implants and develops. Each organ plays a distinct role. The fallopian tube is where fertilization occurs. The uterus is where the fetus develops. The cervix widens during childbirth, and the vagina is the birth canal to the outside. If the fertilized egg implants in the tube itself, instead of continuing to the uterus, it's called an ectopic pregnancy. Because the narrow tube can't stretch like the uterus can, This is a dangerous emergency requiring prompt treatment. Whenever a question describes sperm penetrating an egg to begin a pregnancy, it's pointing to the fallopian tube, the crossroads between ovary and uterus. Question 50. After fertilization, the developing fetus grows inside the uterus for a period called gestation. About how long does human gestation last? Your options are A. 12 to 4 weeks, B. 20 to 24 weeks, C. 38 to 40 weeks, D. 52 to 56 weeks. Take a second. Which answer would you pick? The correct answer is C. Up to 40 weeks. C is correct because human gestation lasts about 38 to 40 weeks, roughly 9 months, during which the fetus develops in the uterus. A is wrong because 12 to 14 weeks is only about the end of the first trimester, far short of a full term. B is wrong because 20 to 24 weeks is roughly the midpoint of pregnancy, not its full length. D is wrong because 52 to 56 weeks is more than a year, longer than human gestation. Gestation is the period a fetus spends developing inside the uterus, lasting about 38 to 40 weeks, or roughly 9 months. This span covers everything from implantation to the moment the baby is ready to be born. Gestation begins after fertilization, when the egg formed in the fallopian tube travels to the uterus and implants in its lining. The uterus is the hollow, muscular organ built to house and nourish the fetus, its thick walls protecting the baby and its rich lining, supplying nourishment as development unfolds. This full length matters because development continues right up to the end, with vital systems like the lungs finishing their maturation in the later weeks. A birth that comes too early can leave these systems underdeveloped, which is why the full 38 to 40 weeks represents the true time a fetus needs to be ready for life outside the womb. The point tested most often is that gestation lasts about 38 to 40 weeks, roughly 9 months. Shorter spans like 12 to 14 weeks or 20 to 24 weeks fall well short of full term. So watch for those as distractors. From fertilization in the fallopian tube, through implantation and growth in the uterus, to delivery about 9 months later, gestation traces the full reproductive journey from a single cell to a newborn. That brings today's Domain 1 review to a close. If you're craving even more practice, our website is packed with hundreds of completely free questions, plus full detailed study guides ready whenever you need them. There's no cost and no catch, just solid resources to help you learn. Simply check the link down in the description to dive right in today, subscribe and stay tuned for the next part. Good luck on your exam.